This is a question from the June 2006 Physics Regents exam. It's number 60. 61? Yeah, 61. 3 kilogram object is placed on a frictionless track at point A and released from rest. Calculate the gravitational potential energy of the object at point A. So they want the potential energy. So I'm going to use the formula P potential energy equals mass times gravity times height. So P E no actually the givens are mass is 3 kilogram, gravity we know is 9.81 meter per second squared, and the height was 3 meters from point A. 3 meters. So now alright, the equation is P equals mass times gravity times height. Fill that in. Mass is 3 kilogram times gravity 9.81 meter per second squared times height was 3 meters. So 3 times 3 is 9. So kilogram times meters is kg. Kilogram times meter times 9.81 meter per second squared. So let me do that in the calculator. 9 times 9.81 is 88.3 around that. So PE equals 88.3. So kilogram. Alright, let me do this. So right now it's kg times m. So it's over 1 times meter per second square times meter per second square. So multiply the numerator. It's kilogram times meter squared over second squared. So that's the same as a joule. So 88.3 joules. That's number 61. That's the answer. Number 62. Calculate the kinetic energy of object at point B. So point B will be here. So they want the kinetic energy, not the potential. So I'll subtract the potential energy here from the total potential energy. So I'm gonna find that out here now. So givens. Again, the mass is 3 kilogram, gravity 9.81 meter per second squared, and height is now 1 meter. Point B, 1 meter. 1 meter. So equation, it's still the same one. PE equals mgh. So analysis. PE equals 3 kilogram, 9.81 meter per second squared, and the height is 1 meter. So this is the resolution. 80. Alright, so 3 times 1, 3, and then kilogram from here times meter, kilogram meter times 9.81 is 3 times 9.81 equals 29.43. So alright, kilogram meter times meter, this is meter per second square. meter per second square. So the same rules again that we had here. It'll turn out to be a joule. So potential energy. It was, how much was that? 29.43. 29.43 joules. So this is the potential energy for when the object is at B, but they want the kinetic energy. So I'm gonna have to subtract. Like I said, I was gonna subtract the potential energy. So 80, 88.3 minus. I could just round that to 29.5. 29.4. 4. Calculator. Minus 88.3. 58.9 basically. 58.9 joules. J. So that's the answer for 62. Now 63. Which letter represents the farthest point on the track that the object will reach? So the farthest point on the track that the object will be able to reach is based on how much kinetic energy it has. And the amount of kinetic energy it has is the same as the potential energy that it started with. So if it starts with, if it's this high, 3 meters, and it has a certain amount of potential energy, that means that all of that potential energy will turn to kinetic energy, and it will still reach this high, like we saw on the ramp. But anyway, which letter for this? Yeah, so the answer is G, because it's the same height. In order to go past G, it'll need more kinetic energy than what it started, than the potential energy that it started with, which is impossible if no forces are added into it. So the answer is G for 63. So alright, number 61 was 88.3, which I got there. 88.3. Alright. 62 was 58.9. Yep, 58.9 joules. And like I said, 63 was G. Alright. So those are 3 problems.